Well, for the Ryman test, to 1 ml of methanoic sodium nitroprusside solution, we add 1 ml of distilled water, 5 drops of acetone, and about 30 milligrams of the amine. So sometimes the characteristic of the color would appear in a few seconds. So it depends. So you just give it like from 1 second to 5 minutes or to 3 minutes in order to get like the final result. For the Simon test, we follow the same procedure as the Ryman test, except that 5 drops of 2.5 molar acetaldehyde solution would be used instead of the acetone. So we need like more than 2 minutes in order to observe the color. The second test is called the nitrous acid test. So amines react with nitrous acid HNO2 in order to give us a diazonium salt. So based on this reaction, so RNH2, which is the aliphatic amines with nitrous acid, and in presence of hydrochloric acid, as you can see here in this equation, it would give us diazonium salt. As it's represented right here, Rn2 plus and Cl minus. This is the diazonium salt with water, spontaneous decomposition. It will end up with the releasing of nitrogen gas and production of alcohol and alkyl halide and ether and alkene. With the aromatic amines, this is a representation of any aromatic amine. For instance, we could use aniline with the nitrous acid and in presence of hydrochloric acid, the same as the previous one. It would give us diazonium salt as well. It's stable at 0 Celsius. With water, it will produce nitrogen gas and alcohol plus hydrochloric acid. So these two equations represent the reaction of amines, aliphatic and aromatic amines with nitrous acid test. So secondary amines undergo a reaction with nitrous acid to form N-nitrosyl amines, which are usually yellow oils or solids. So it could be yellow or oil or solid depending on the molecule that we are dealing with. Um, so let's take this example. We have dimethylamine, for instance, with nitrous acid. It gives us this molecule and nitrosamine with water molecule. As we just said, it could be oil or solid. With tertiary aliphatic amines, this reaction is not suitable for that. It would not react, but it will form a soluble salt as represented by this equation. On the other hand, tertiary aromatic amines react with nitrous acid. So let's just like pay attention to this point. So with tertiary aliphatic amines, the reaction would not be occur. So we could distinguish between aliphatic or tertiary aliphatic amines and tertiary aromatic amines using nitrous acid test. This is really soluble and really important for the distinguishing between these two type of molecules, aromatic and tertiary aromatic amines and tertiary aliphatic amines. With tertiary aromatic amines, it will react with nitrous acid to form organic colored hydrochloride salt of the C-nitrosamine. So treating the solution with a base liberates the blue or green C-nitrosamine. So here is what happens when we react any tertiary amine with HNO, which is HNO2 nitrous acid with the HCl as an acid. It will give us this molecule, which is hydrochloric salt of C-nitrosamine. The color of this molecule is orange. So when we treat that molecule with sodium hydroxide, a strong base, it would end up with a green color, which is C-nitrosamine. This molecule is green color, so you should pay like attention to what happens to the colors changing. Now, this is the procedure that you guys are going to conduct in the lab. Nitrous acid is prepared instantaneously by the reaction of nitrate and hydrochloric acid. So NaO2 with hydrochloric acid, it gives us nitrous acid with NaCl, table salt. So in a test tube, 0.5 ml or 0.5 grams of the amine. So amine could be as a solid or a liquid. So if it's a solid, so you take 0.5 gram, and if it's a liquid, you take 0.5 ml. In a mixture of 1.5 ml of concentrated hydrochloric acid and 2.5 ml of water, and cool the solution to 0 Celsius in a beaker of ice. So you need a bunch of ice in order to get this reaction done. In another test tube, dissolve 0.5 grams of the sodium nitrate in 2.5 ml of water and add the solution dropwise with shaking to the cold solution of the amine hydrochloride. Move 2 ml of the final solution to another test tube, warm gently, and examine for the evolution of the gas. Result: the observation of the rapid bubbling of the forming as the aqueous sodium nitrate solution is added to 0. Celsius indicates the presence of a primary aliphatic amines. So this is the indication, okay? And the evolution of gas bubbling upon warming to room temperature indicates the amine is a primary aromatic amine, and the solution should be subjected to the coupling reaction. Pale oil or low melting solid, which is the nitrosamine, is formed with no evolution of gas, and dark orange solution or orange crystalline solid is formed, which is the hydrochloric salt of the C-nitrosamine. These are the results that you should obtain, so you can depend on them in order to determine what you have already obtained. Well, this is the third reaction. It's called the coupling reaction, which is a test for primary aromatic amines. So as you can see here, so we have diazonium salt or primary aromatic amines with sodium nephthol, and in presence of sodium hydroxide gives us the azo dye or red orange color molecule with sodium chloride, table salt, and water. So the procedure of this test is we are going to dissolve 0.1 gram of 2-nephthol, all right, in a mixture of 2 ml of 10% sodium hydroxide solution. So we need to prepare that solution, 10% of sodium hydroxide and 5 ml of distilled water. Then we add 2 ml of the cold diazonium solution and observe the results. So at this point, we should know what we must obtain. So the formation of red-orange dye, which is a red precipitate in case of phenol. So if you use phenol, then you must obtain red precipitate with evolution of gas only upon warming indicates that the compound is a primary aromatic amine. So this is the indication of a primary aromatic amine. Well, this is the fourth test, which is carbon disulfide test, which is test for secondary aliphatic amine. So when we write down R, which means it's an aliphatic amine or aliphatic molecule, when we write down AR, which is aromatic. So you gotta be attention, or you gotta be careful at this point. So R is for aliphatic and AR is for aromatic. So we have R2NH, a secondary aliphatic amine with the CS2, which is carbon disulfide. in presence of ammonium hydroxide, so it should give us dialkyl dithiocarbamate, which is this molecule on the right side. So with nickel chloride, it will give us this complex. So for the procedure, so we dissolve 50 milligram, which is 1 to 2 drops if it was a liquid, of the amine in 5 ml of distilled water, or 1 to 2 drops of the concentrated hydrochloric acid if necessary. Sometimes we need to use hydrochloric acid to get the powder of the amine dissolved. So this is the first test tube. So in another test tube, we mix 0.5 to 1 ml of concentrated ammonia solution with 1 ml of nickel chloride and carbon disulfide reagent, and NaCl2 and CS2, which is carbon disulfide. So we add 0.5 ml from the first test tube to the second one. So we mix some from the first tube to the second one. A different precipitate indicates that the unknown is secondary amine. So this is the indication of the secondary amine. A slight turbidity is an indication of the trace of a secondary amine as an impurity. The fifth test is lignin test for primary and secondary aromatic amines. So this is a specific test. So this test depends on the action of lignin in the newspaper. So we should use like a newspaper in this test because it will change the color of that newspaper. So we need the material of that newspaper, what it had. So the newspaper could have lead, right? So so we gotta be attention to that. So we cannot use like any kind of paper. So because we meant to use the newspaper because of what it's made of. So we dissolve 10 to 20 milligram of the amine in a few drops of ethanol and moisten a small area of a newspaper with this solution. So we place 2 drops of 6-normally hydrochloric acid on the moisturized spot. The immediate develop of a yellow or orange color is a positive test for primary or secondary aromatic amines. So the sixth one is the azo-di formation of the aromatic amines. So we take 3 test tubes. This is the first one we are going to use, and place them in a rack tube and label them ABC. And we place a small quantity of the organic compound 0.5 ml in the test tube A, and we add to 0.5 dilute HCl and shake the test tube to dissolve the compound in hydrochloric acid. Third is to place a small quantity of sodium nitrate in a test tube B, and we add 0.5 ml of distilled water, shake the test tube very well to dissolve the sodium nitrate. Fourth one is to place a small quantity of beta nephthol in the test tube C and add 0.5 of the dilute NaOH, sodium hydroxide, and shake the test tube very well to dissolve the beta nephthol. Fifth one is to cool the 3 test tube in a beaker containing ice water for a bit of time. So we need to create an ice bath in order to get the reaction done. So finally, we add a test tube B to the test tube A, then we add the resulting solution to the test tube C. So you have to pay attention to this point. So you do not like mix C and A and then you add them to the B. So we need to get a reaction done first, which is between A and B, and then we react the result or the produced molecules with compound C or test tube C. So you should obtain a scarlet red color of iso dye.